So how do you measure something you literally can't even see?
It's a huge challenge for scientists. How do you find out how much of something is there?
They use this really cool tool called a calibration curve. It's basically a custom-made ruler.
Yeah, with this ruler, you can measure the invisible. So how do you even make one?
It's super important. It helps make sure our medicine is safe and our water is clean.
Okay, so making this ruler, it's actually just a simple 3-step process. The whole point is to get a nice straight line, just like a regular ruler.
And here's a real one. This curve helped develop a new anti-cancer drug. Pretty amazing, right?
You know, behind that straight line is a really simple but powerful equation. Let's check it out.
Okay, we've got the ruler, we've got the math, so how do we find our mystery amount? So Y is just the reading from the machine, but X, that's the prize. That's our concentration. Then, with a little bit of high school algebra, we just flip the equation around to find X.
So you measure your sample, get the Y value, plug it in, and bam, you've got it.
But hold on. A great result needs a great curve. You wouldn't trust a wobbly ruler, would you? For example, if your points are all bunched up, one weird reading can totally mess up your line.
And you know, there are a few other common mistakes people make. Let's look at them. But the number one rule, seriously, just plot your data. Always look at it first.
So how do you know if it's a good line? There's a score for that, called R-squared.
Hey, remember that anti-cancer drug? Its R-squared was almost perfect. That's a ruler you can trust.
So what's the secret sauce? Plan well, randomize your samples, and use good equipment.
It's really just an elegant way to turn a simple signal into a super precise measurement.
So now that you know this secret, where else do you think this custom ruler is being used?